Hi, I'm recording a step-by-step solving of a problem in section 12.1 on tangent lines because I find that the problem is a funny one to have as an introductory problem. Because it's such a complicated problem, it implies that tangent lines are complicated, and they're not. So I'm going to go through this problem step by step, and you can rewind and watch this video as many times as you want until it seems like not a big deal. Alright, so this problem, first of all, is supposed to be just teaching about tangent lines. Tangent line says that if you have a radius and a line tangent to the circle that touches that radius, it's perpendicular. So if a line is perpendicular at the radius, it's a tangent line. So if you see this pattern, a line, a radius, it should be perpendicular. So that's the tangent line. And they came up with a pretty complicated problem. But before we go to the problem, it tests the second idea that comes from chapter 3, which is this. If you have a perpendicular line, two lines that are perpendicular, and you have a parallel line to the original line, then it's also perpendicular. So let's say it the way they say it, which is much better. In a plane, if a line is perpendicular to one of two parallel lines, so here are the two parallel lines, then it is perpendicular to the other. So you have these two parallel lines. This line is perpendicular to one, therefore it must be perpendicular to the other. That's something that this problem tests from an old chapter. Alright, hold on one sec. Okay, so here's the problem. It's example 2 on page 663. You can read the more detailed description in the book, but it's basically a dirt bike chain fits tightly around two gears. The smaller gear has a radius of 2.4 inches, and the larger gear has a radius of 9.3 inches. And they want to know this distance from the center of each gear. Now, the first thing that I'm going to show you is that, one second. If we just draw in the center, we have kind of an odd quadrilateral there, and not one that I find particularly helpful. So they do something clever, and it's so clever that it makes tangent lines seem complicated when they're totally not. The problem is a little complicated, but tangent lines are very simple. So I'm going to show you what they do. What they do is this. One second. Well, remember that funny quadrilateral we had? Well, what they figured was, if we take the radius of the smaller wheel and we make a rectangle, so this over here is the radius of the larger wheel, and we make first a rectangle here using parallel lines. So because it was a tangent, this here is a right angle. Because we're told that we're going to draw a parallel line, this is also perpendicular because it's two parallel lines. This one's perpendicular to this line, so therefore this one's perpendicular to this line. So if you notice, what we now have here is a rectangle and a right angle. And now this is something that we can work with, right? A right angle, and this is the thing that we're looking for. A right angle is something we're comfortable with, and this odd quadrilateral is not. So basically what they did was they drew in a rectangle and a right angle. Very clever, nothing to do with tangent lines, just clever construction. Here, hold on one sec. So as I said, how do you know how wide to make the rectangle? You make the rectangle exactly equal to the radius of the small wheel. So if this over here is the radius of the small wheel, because it's a rectangle, so is this. Alright, hold on one sec. So now comes this, complicated looking thing, which is not complicated. So we have this 2.4, right? And this whole thing here is 9.3, but we draw a rectangle so that this side is also 2.4. We were given that this side is 26.5 inches, and because it's a rectangle, this side is 26.5 inches. So there's our rectangle, 2.4 by 26.5 by 2.4 by 26.5, right? Then, because of parallel lines, we're told these are parallel. Let me just mark that in. We're told to draw these such that they're parallel. Then we know that if this parallel line is perpendicular to this radius, this parallel line is perpendicular to this radius, and now we have a right triangle which we are happy with. Now how do we get this little piece of the right triangle? Well, we know the whole large radius is 9.3. We know the rectangle that we carved out, the piece is 2.4. So this piece of the right triangle is 9.3 minus 2.4, which is 6.9. And now we just have a right triangle Pythagorean theorem problem. So one second. So now we have this 26.5. This purple is what we're looking for, AD. And 6.9 because it was the large number, which was 9.3 minus 2.4. So we have 6.9, 26.5, and then the hypotenuse is what we don't know, but that's the distance between the center of the two wheels, and that's what we want, and we just use the Pythagorean theorem. AD squared equals 6.9 squared plus 26.5 squared. AD squared is 749.86. AD is about 27.38 inches. Alright, so that's how you solve it. I would take a look at this video 3 or 4 times. It makes you think that tangent line problems are complicated. They're not. This particular one was unnecessarily, but take a good look at it. Alright, take care.